Hi, and welcome to a Technia Transcat webinar. My name is Rehan Chaudhry, and with me I have Laurent Couillard, who is the founder of Optim Data, and Antoine Yuen, who is the UX manager at Optim Data. What we're going to talk about today is how a data-driven approach can help increase aftermarket revenue. The idea is that we at Technia Transcat consider digitalization as a great opportunity for the industry. As a result, we have invested in a new R&D center specialized in developing applications based on industrial Internet of Things and data science. The first application released from our R&D center is called ProductInUse, which aims to help increase the aftermarket revenue for industrial companies. At the end of the webinar, we will present an option on how to engage in a proof of concept evaluating your own data. Laurent and Antoine will lead you through the rest of the session. You have all been muted, but if you have any questions, feel free to post them in the questions box in the GoToWebinar client, and we will try to address them at the end of the webinar. So, let's get started. Laurent?
Thank you, Ryan. Hello, everyone, and thank you, Antoine, to be with me for that webinar. So let's enter into the subject that you presented well. How we can, with a data-driven approach, increase aftermarket revenue. And let's view first what are the key challenges that the Industry 4.0 must deliver. The first one is definitely a market evolution of the industry, moving from a product economy to a service economy, and even though the sharing economy. So for an industry market standpoint, changing the game by developing a product, selling a product with services to an environment where the services are the center of the what to sell is a real transformation. How it is enabled? Technological offers are maturing a lot. Internet of Things, of course, and data science, which are the two pillars that Optim Data is developing on, are the enablers of that transformation. But not only that. We have to consider the way the users are empowered. This is not a total digital chain that we are looking for. There are people acting on the chain, and they are acting on the industrial environment. Therefore, the organizational model and the user empowerment is definitely transformed. By providing data to many people at whatever level of the hierarchy, you empower and you increase the user performance. As we should say also, we augment the user. All of that is done in a sustainable environment where having more information and data sets increase the traceability, mostly because the demand is getting more complex. The demand of the market is always being more complex, and we move from mass production to mass customization, and mass customization means many small units, many small numbers of produced units that you need to have traceability on, and that's the element there. And of course, to do that in an environment where the manufacturing sites and all that must be eco-friendly and limiting the waste. And it has a social impact because the world is definitely global, and the market is really global. However, in the value chain, we have to act global and local, and we have to manage that in a common sense. And there are some fundamentals provided by the web industry, the internet industry, that are making things global while they are played local. And the experience and the user environment is something that can be shared across many culture and many people there. What is bad then is digital transformation, and digital transformation is close to the data set. And in Optim Data, what we say is we value data first. Digital transformation has, in fact, generates more data in the past 10 years. Everyone in the company is looking for digitalization of their processes, and the way you can develop the better your activity. This has bring to siloed information, but also to generation of a lot of data to make minimum, to make optimum of the processes that I would consider them as being local optimum. But the effect is you generate more data, and it's quite common that when we meet customers, we meet industrial companies, the number of data is huge. The way we work in Optim Data is a little bit reverse. We start from another side. We start from the usage. We start from how the knowledge that we can capture on the product in use can filter the data and then define which one we need to capture. So we reverse the paradigm of the Internet of Things, starting from a product, the connectivity, the data, and then you see what you can do with the data, from what can we do as new value from the business we are looking for, and then what are the data that we are looking we can access, or the data that we miss, and then we go the other way around. Why we are doing that? Because we've got a strong belief in a very important change, and that will become the game changer for many industries. What we consider is that instead of being in a transactional approach of sales, where a product is sold together with services, and that's the type of relationship which is a transactional relationship, we consider that tomorrow the sales will be about to enhance the performance of the product you've sold within your customer side. It's really about how you can help your customer to do better with your product. The product that you sell is still the physical link. This is an important asset that makes the link very resistant between the two parties, but helping them to overachieve their goal with your machine, make them more loyal, make them more keen to look at your services, and transform the business and sustain the business into a kind of machine as a service business later on. So this is what we're going to illustrate in a demo, and the way we do that in our targeted market, which is the industrial equipment, mobile equipment, medical devices, or energy like the wind turbines and the solar renewable energy market. What we have considered in the chain is we have granted the machine at the level of the human, and we say the machine should be able to talk to you, give you all the advice and the way the machine feels in order to help you to overperform in the production side. Let's look at what it means in some views. First, we said empowering the user. So line operators, maintenance agents, call center agents, product managers, we have to make the map of who are the key users around the value chain. We're going to do a demo on a machine, a maker called Fabricants. So he's a leader in can machines for beer distribution market. So it's an overall demonstration where, in fact, the machine they sell is a combi made of two stages. It's two types of machines that have been combined. One is building the cans, and the second one is filling the cans. And you've got a kind of process flow where you've got the aluminum coming, then you blow the can, then you put the capper and you fill the can, and then you put them on the conveyor, and then they go on the track. The role I will play in that demonstration will be row maintenance, working for Fabricants as a role of technician expert at Fabricants. The customer that Fabricants have in the connected environment is Lamab, SPBF, Blo-du-Bois-Fils, Blondel, and the last one. And we're going to do the demo with two customers. The one will be Lamab and the one with SPBF. Lamab having two sites and SPBF having one site. The person that will be acting is Mark Belt in Lamab. He is the line operator. He is the one who is driving the production at Lamab for the first line. And also, we'll see if Maximator can contact us during the demo at SPBF. Let's enter into the demo. So as I told you, I am maintenance, and I am responsible for the fleet. I'm the technician expert, okay, and this is my profile, and I have access to a set of customers. So I am following in the sense of Twitter. So everything that is happening on those customers, I'm aware of. I'm following 18 producers or 42 sites that represent 41 machines. So there's one site that the machine has been sold but not yet installed. That represents a number of units produced since the 21st of January up to today, and I've not made any intervention yet during that period of time. This is my fleet of machines that are acting, and some are producing good, some are producing a little bit less in terms of availability of the machine and the type of production, depending on the criteria that we've set there. Let's look to LAMAB. We discussed about LAMAB, and let's look at LAMAB sites. And as I told you, there's two sites. We're going to look at the one in north of France called SOX. Basically, there's a combi, so they bought a combi of fabricants. And currently, the availability of the combi is quite good, 93%. But before we enter into the online connectivity, let's have a look to the story of that line. The story of that line is quite simple. Okay, here in one view, I can have the full history of the line, which is the assembly of many sources of information that I have in fabricants. What it is? The first line is the mileage of the machine in the sense of the number of produced units. So here you see the bar, which are the weekly production site, and I have produced 2.5 million cans this week. Okay, and the cumulative line is 30 million cans starting from the beginning of the life of the machine. This is the first type of mileage. The second mileage is how many working hours have been used to develop the production. So 121 in that week, but 2,145 at that time, which was on the 6th of May. Those mileage are very interesting if we combine them with the key milestone of the machine. And the key milestones are referred by the tags, the blue tags that you see at the top. Operation starts at the beginning, so that was beginning of 2015. 3,000 hours and 6,000 hours, which are the key important plan maintenance organized for the customer. The end of the warranty support, so very important, is you've got a warranty period when you sell a machine, and then you've got a start of support, so you sell a maintenance contract afterwards. And we are now in that time, so we are on the 28th of January at that time. So this is the current position of the machine. So the mileage is helping to understand what did happen there. Why? We've got the rate of the machine, which is the production per week of the cans. So it's about 16,000, 14,000, and so on. So this is the current speed and cadence of production. And below that, we put the availability of the equipment. The availability of the equipment is based on the standard of the industry. We compute the OEE, the overall efficiency of the equipment, and we extract from that the performance, the availability, and the quality. Here we represent the availability as being one of the key KPI for understanding what did happen on the machine. And basically, there are some obvious situation. For example, when you have a planned maintenance like the 3,000 hours and the 6,000 hours, the availability is decreased to a low level because the machine has been stopped for doing the planned maintenance. So you've got a lot of controls, cleaning, and also spare changes to do in those period of time. And of course, the number of hours that have been used in the week, there was not that much production and not that much working hours there. But we can see also that during the 1 year life of that system in production, you have the lower availability, which is red in that zone here, so something like the 6th of March, the week of the 19th of May, and you've got some the 6th of October and the 3rd of November. So these have been events happening on the production system that have been decreasing the availability or showing a decrease of availability of the machine, that can be analyzed and maybe is a reason for the type of relation fabricants has with LAMAB in terms of satisfaction of the customer. By the way, we have also aggregated the interventions. So we know that people from fabricants have been acting on the machine either remotely or in local intervention. Remotely is we connect to the log of the team viewer of fabricants, and they use team viewer to connect to the machine and to change the parameter on the machine, and we get the log in order to know how long they stay in team viewer and what have they done. And also we have the ticketing system for the live and physical interventions. So you've got local interventions in yellow and remote intervention in gray in that graph. And finally, based on all those information, we are able to compute costs. We are able to compute the view of the performance, the financial performance of that customer. And you see here in the warranty period, there was a kind of cost phase until the warranty end and the customer LAMAB pay for a monthly fee of maintenance, and that the break-even have been back in something like on the 14th of November. And up to now, it's growing in terms of performance, which is a benefit for both. Benefit for LAMAB, because LAMAB is having an available production system, and the high availability is important for him to maximize the uptime. And it has been also very interesting for fabricants because it's a profitable business to do the services there. Let's have a look to the machine then. The machine currently is producing, and as I told you, it's a machine that produces beers. So they have been producing Heineken, Budweiser, Lef in the last period of time. So we are on the 28th of January, and it is 10:18 a.m. And we see the value of the machine. The performance of the OE is a little bit decreased, 80% in that period of time. 90% availability, a good performance, 91%, and the quality quite high. That's the number of units that have been produced in the last hour. I've been warned that as we are on a given date in the week, I have to do some weekly maintenance. So the system suggests and track if the weekly maintenance or any other application and orders are done by the operator. So this is where we can act and suggest that. You will see that more in the next phase. Let me tell you a little story about this customer. We're going to look at the situation that happened on the 14th of December. 14th of December, the application ProductInUse through the robot. So this is, you can see that as the machine talking. The robot is the language that the machine is using in order to tell how she feels. And the robot indicates that there's a job failure at configuration. The second thing that did happen on the 14th is, oh, but my feeding valve are not progressing well for the valve 11 and the valve 29 during the production cycle. And just next is Mark Belt, who is the person in charge of the production at LAMAB. Just take a conversation, so a chat with me, to say, hey, I have probably some issues there. Can you check what's coming in, and can you connect in remote to help me to configure better the application and the machine? And that's what made Romain at the same time. So we are still on the 14th at 4:41. He has connected in remote, and we've got the log of access. So everything that we record here is called the else record. It's if you want to be able to diagnose a situation on production, you must have, of course, the machine data information, but you must have the context of the machine expressed by the people around that. So it's not the machine alone, it's not the people alone, it's a combination of the machine and the stakeholders of the value chain there. Maintenance being part of that, Mark Bell being part of that, and trying to assemble all the multi-channel into a single view that express the context and the understanding of the situation. Let's have a look to the global situation on the 14th then. And let me show you the day here. So here you have a view, a single view in a graph that we are patenting. This is the Optim data graph here, where we represent the complete set of production during 24 hours. So we start on the 14th here and we end on the 14th. What is happening there? You have the jobs of production, so the Corona, Dove Beer, HT, and so on. Then you've got the status of the machine. We have in green, the machine is producing. In light green, the machine is running, meaning it's available but not producing. Then in yellow, it's setting. The machine is configuring to adapt the production to the right order of production. And in red, the machine is stopped. So basic four views here. We have examples and experience having much more level of production time. In the graph here, you see the cadence of production. So we represent in blue line the number of bottles that they produce per hour, so 13,000. And the green line is the production unit count. So you see the growing product unit per job. And you've got a set of errors that the machine is delivering. So these are error codes, and these are the name of the error. That's not always very obvious for the line operator, by the way. There are many reasons for the line operator not to really understand what does it mean there. So the reason of the marker that you see below, bad job start and valve filling too long, is to express in a simple language what does it mean. So what means a bad job start? A bad job start, we're going to look at a good job start. A good job start first is you have a change, so you change from Amstel to STI. You launch the production with a given percentage of the full power, okay? And then you wait for a number of units, here 176, then you can go full speed. So there's two steps of growing the cadence of production. Probably because the operator was late in his production time, he wanted to accelerate the load of the machine, and he tried to set a value here that was the top value at the beginning. That was not able to work with the machine, so that the patterns of start here is not representing the standard pattern there. That's why automatically the system indicates to the operator that you do a bad job start, and he can provide the right procedure to optimize the best job start to do on that. Then if we continue on the stream, we see that this job here have produced a lot of errors, and that error are due probably to the valve filling time too long, which then be back on the normal production side, and then have been replicated a second time in a period of time. And the blue line here represent the interventions that maintenance that I did in remote in order to reset the machine to the proper parameters. So this is the purpose on that. Let's go back to the next part of the story. So I've been on the remote access performance, okay, and in the discussion that engaged afterwards, so Mark said, I've seen the marker valve issue, then you change the parameter, but do you recommend that we're going to change the valve for the 50 centiliters at the next shift? And of course, Romain was really saying, yes, you should change the valve as it is said, because you will lose more and more time in the filling period. So when you can, stop the production, change the 2 or 3 valves that have been indicated by the machine. The machine told which valve is in failure, and do that. And the day after, on the 15th, in the morning, when Romain reconnects, he validated that the change of valve have been done and the system have been correctly done. Why that? Because we can see the change of valve here. So Mark has changed the valve almost at midnight, so that's probably not the best hour to do it, but at least he did that. How is doing it? Simple. is connecting to the, is getting out of the stock 3 valve, is mounting the 3 valve, and then is taking the picture into the application, putting a small comment in the system, and that's all. He has nothing to do more than reference that. And what's next here is automatically we generate with that spare change a marker, an automatic sequence detection that indicates if the spare change has been positive or negative in the context of the production. And if we look at that, and I'm going back to the diagnostic form here, we're going to extend to 2 days of production. Okay, and here the 2 days, I have the errors, the second job that have been in error, the intervention of mark here, and my marker at the end, that because the next production type has been correctly done with an OEE at the right level, we can validate automatically the change of spares. This is the purpose of that. So here what we have illustrated is we're able to understand the context and change the schema of the large error codes to a language that is workable for the operator. That's something that we can automatically detect as a sequence mining into the system, which is the data science part, one part of the data science of the application, and then launch and propose the right action to the user in order that he is optimizing his uptime. So this is the view. Let's discover a little bit more the production type. And let me show you something. By the way, I have received a notification at the moment, and I have a machine in failure since 7 minutes on that. So you're going we're going to connect to that customer very soon. I just want to finish my presentation of LAMAB. But I have just had a notification of one of my customer in deep trouble. So here is my production line. I've got the view of the number of units that I've been producing from the beginning of the year to the end. I've got the format, so I can run the different format. For example, I can select the 75 centiliters cans. So here is a 75 centiliter can, and I can filter everything, so I can identify in a given period of time how many cans I've produced of that kind. I can resume that period to this side of the period, and in that time, okay, which is basically from May the 11th to something like November 2015, I have produced 7 million of 75 centiliters that have been done mostly for, let's say, Stella Artois and Budweiser. Okay, that the availability of the machine of the line have been quite good, 90%. Almost 90% there. The performance very, very good over the limit, and the mean time before failure. So the error check is 13 minutes, almost 14 minutes. It's cost 1.5 minutes to recover the downtime duration and the rejected units, and we can analyze that for each of the stage of the machine. So this is for the press of the cans, and this is for the filler of the cans. Okay, so. And we can see the key errors there. So, for example, if I check for that error, here what I have is for 75 centiliter bottles, okay, during that period of time, what is happening when I am in that error for the can press view here. So I can have the figure here, I can understand what is the status of the machine, I can understand the value of the downtime, I can understand the number of bottles, the quality here of the rejected units, and so on. So here this dashboard is made to really open all the access to the technicians to understand within the past how much the situation happens and what could be the cause of the situation. And finally, I can do that on a machine, I can do that on a set of machines, and I'm going to illustrate that by the synchronization aspect. Remember, I've got the press on one side and I've got the feeder on the other side. What can I do is I can say when my press is in production, okay, here my press is producing, and it's running. My feeder is producing at 85%, and it's running, meaning it's available, but not producing, because of for 13% it's running. On 65% of this 13%, it's because the downstream, and it's because the conveyor to extract the cans at the end of the filling stage is not available. So we can build very easily, thanks to the magic of the data assembly, the view of the full line and check the status of it. So this is the view for LAMAB, and as because I have been warned that a machine has failed, I'm going to connect to this machine. Totally quickly, I'm changing. I'm at the second producer called SPBF on the site of Greeny on line 1 on the combi, and basically it seems that there were some errors, the skull, and they were not able to produce there, and my marker shows that machine has failed more than 3 times to complete the same job. So let's go to the on air, and by the way, let's see if I can be connected to the person there. So here I've got a recommendation. The recommendation has not been done yet, and I should have the communication to the operator here. So the production is there. Automatically, the system has detected that the machine is in failure. Okay, more than 3 times. It continued to be in failure, by the way, and so the system is proposing some actions. Restart the machine and apply the following settings, or check the machine barometer. So what we can do here is we can wait, or we can connect in chat with the Maximator, which is the line operator of the system, to do that. And we are going to check the fact that we can recover the action there. So why we can do that is because in the system, with the aggregation of the full set of data that are coming from one machine, that are going from a fleet of similar machines, that are coming from the action log that we have with the else record view there that you've seen, what we can do is we can create sequence. Sequence is a schema that is identified by a technician somewhere in the fleet of machines that have an action that can be associated to, and then have a triggering approach, which is the capacity to happen. And in that view, we can, in the live view, detect what is happening and propose the evolution of the action. So propose to the right operator the right action. This is what I wanted to illustrate in the demo. And of course, this covers the producer, the machines, and the manufacturer key values. Either qualitative ROI, so really something that we can measure and that we can run there, or soft ROI, which are much more on the view there. A few examples that we can do. How you can develop more business. If you look at the upgrade, we can propose an upgrade of the machine in the real context of the customer. If you know the way the machine is producing, and you can adjust the value of your upgrade to the customer, we can help to really justify the acquisition of an upgrade for the customer in his context. And you can benchmark that upgrade to similar machine as soon as you work on the fleet side. Another type of is the capacity to coach the way the producer can do and perform better on his production system, which will be done by really analyzing the data sets of the customer and suggest how he can do better. One of the key criteria that we've been looking at is the changeover. I mean, how you reconfigure on the mass customization production system, how you reconfigure the machine that you can help them to go quicker in every change and react quickly to the customer demand. So at the end, the producer sells more, he uses better the machines, increases loyalty to the manufacturer of the machine, and all the chain is really increased in terms of value. And as you've seen for the marker that validates a change, we can also check maintenance procedures or do any kind of check that we help to coach the customer, the producer, to do better in his own performance there. Finally, something that has not been illustrated yet into the application, and that we would like to do in the context of personal data of industrial companies, we can add to the marker a behavior that we call predictive analytics. Predictive analytics is the way, when we see the map, to see not only the on-air, so which is the connected machine right now, but also to forecast what would be the conditions of use of the machine in the next coming weeks. So, for example, in that example we are working on, we're going to produce the map of the similar machine, but the red and the yellow dots are indicating that the red one is there's a high risk of failure, of one type of failure that we can identify in the next week, and the yellow one is it's probably coming in the next 2 weeks with a high rate of that. We can do the kind of metrics. It's project dependent, but this is the algorithm that we can do based on the aggregation of the data that we are doing. All of that is done, and as Ryan said as an introduction, we are proposing a step approach to deliver such kind of value to your context. The first thing is to replay the ProductInUse environment within your data. How we do that? We do an inventory of the data first at your site. We identify what are the meaningful information, what are the missing information, and what are the ones that may not be very interesting in the context of the kind of services that you want to deliver. We always focus on the value of the data for you. So the system is made that at the end of the first period, we have a prototype that illustrates a few services that deliver value and that differentiate a manufacturer of a machine on the market, because the services that will be delivered will be higher level than the standard services, which are remote access 24/7 and spare planification, but really giving the constant link to the environment. First period of time, 3 months, being able to prototype that and deliver the value of the services as a draft view. Go-no-go phase, and then we enter into a phase where we would suggest to connect to real producers that could be the early adopter of the program, and we validate the full chain from connected machines to the user in operation. So we really create the global collaboration between manufacturers, the people building the machine, the people running the machines, and all the language that we create there. And after that period of time, which might be something like 3 to 6 months, depending on the size of the machine and the complexity of the line, then we can deliver an in-use solution in the context of the customer. So digitalizing an industrial company, proposing a new type of services that integrates the visibility of the machine, that integrates the capacity to contextualize the machine, that integrates the capacity to design the marker for your context. So really integrate knowledge inside the system depending on your production system, and then being able to develop a new offer, which will be a differentiated offer, being connected, being web-driven, being modern on that, and beneficial of all the technology that exists on the market, from data science and Internet of Things.
So we actually have some questions posted, and one question is besides OEE also TEEP, total effective equipment performance measured, for example loading, etc.?
In fact, we want to reflect the computation of the customer. So we usually come to the raw data and then we rebuild that. OEE is the standard for for flow machines. We, as you see on the chart, we use a lot of the standards that are provided by the VDMA in Germany. But definitely these are maths behind the data, and we can comply to other way to compute the right key performance indicator. What we differentiate in the KPI that we are manipulating is, I would say, two categories. The one that are driven by the machine itself, so by the equipment itself or the line, because this is what the machine provides as data. And then there will be also the one that are linked to the performance where the human can bring in. A machine can be available, okay, without any raw material at the entrance. It's a question of process in the factory, and we need to divide that so that we can shape the right service to coach not only the machine but the total line there. And what is important is to adjust to the right meaningful KPI so that the coaching is very efficient. So the answer is yes, we could cover this this way of computing, even if it's not OE that such. And for the customers we are running, we have slightly changed or defined and converged to the OE that they are using.
Okay, perfect. Next question is, does your development roadmap also foresee prescriptive maintenance?
Correct. In fact, what we call prescriptive, we've got two very important subjects in the development. The first one is we are going to develop in the next 2 months a part of the application to design the marker. So all the magic of that, all the key kernel of the application is the way we manipulate the data. That's the background. Now we want to leave to the user the capacity to develop his own marker and identify the right sequence and replay and simulate the right sequence in all the data sets. And from that sequence, attach an action. And that's the first step of prescriptive by having the sequence mining, so sequence detection connecting to an action. That's the first way we answer to prescriptive. The second way we answer to the prescriptive is what I've shown in the last chart that we do on fleet view. You can do prescriptive, which is the association of predictive and an action. You can do that if you are able to build machine learning environment on a group of equipment.
Okay, next question. When the internet connection is unstable, is there a possibility to cache data in order to synchronize later?
The answer is yes. We can buffer and then get the data afterwards, of course, because that's depending on the line and the way to organize that. So definitely it's possible. We have also, when we were saying about the machine data, the ping of the connection between the equipment and our cloud is important, so that we know that if we do not receive data and that the ping is off, then there's a problem of communication and we are going to receive the data and recorrelate the data later on. The buffering is totally possible because what we care of is we synchronize and we correlate all the data on the time axis, and the data, the logs, are stored with a timestamp, and we do that. So the answer is yes, we can buffer on the equipment side, or we can buffer somewhere in the chain for the communication. Important is to have exogenous information on top of the machine data, like the line availability, the communication line availability, to make it visible for the entire chain.
Last one then. Can you explain how you differentiate from traditional MES solutions?
I really want people to understand our positioning here is what we want is to listen to the machine that are making the production, and the quality of the product that is built by the machine is one input. We do not ensure the traceability of the quality of the product that is produced. We want to listen and equip the production system in order to make it the most efficient. And that's really a positioning that we have into the market, which is to equip production line to understand the way they are behaving, and the product quality and the product traceability that they build is one of the input.
Okay. All right. I think time is actually running out. We need to wrap things up. And first and foremost, I would like to thank everyone for attending. If you have more questions and the questions we haven't been able to answer, we will please send an email, and we will also try to contact you, the ones we haven't been able to answer. And yeah, thanks again for attending. Thank you, Laurent and Antoine, and have a great day, and goodbye.
Thank you, and you can of course follow us on ProductInUse website, where we are posting blogs and articles, and also our view on several technological points. And so do not hesitate to contact us through ProductInUse.com or to follow us there. Thank you very much for attending the webinar, and talk to you soon.
All right, thank you. Bye.